Alright, so today we'll be talking about discrete random variables. Okay, now random variables is let's say x, is a simple variable whose value is a numerical outcome from a random event. Okay, so for example, let's say that we were talking about someone hitting home runs in a baseball game. Okay, discrete random variables, there must be a countable number of outcomes. Okay, so in other words, let's say that a player had hit a home run about, let me see, they'd probably not hit a home run about 80% of the time, so this would be 0.8. Okay, they'd probably hit a home run about 0.1% of the time. They'd probably hit two home runs about 0.7, no, not 7, 0.07. Okay, and then three or more home runs, and this is obviously very statistically skewed. Okay, about 3% of the time. Okay. Okay, so here's our numbers all set up. Okay, so this is all of that stuff. So what we can do is we need to first make sure that that adds up all to 1% or 100%, which it does. Okay, then we can start finding probabilities. So let's say the probability of x being equal to 0. Okay, now the probability of x being equal to 0 is 0.8. Pretty simple. Okay, now what about the probability of x being greater than 2 home runs? Okay, well that would be the sum of both those. Okay, so that would be the probability of x equals 2 plus the probability of x equals 3 or more. Okay, which would actually just equal about 10% of the time. Okay, this is a prolific home run hitter according to this data. Usually you hit about, I mean, that's once every 10 at-bats, or once every 10 games, you know, you're hitting 2 or more home runs. So that's pretty nuts right there. I mean, to have that kind of stuff is just crazy. Okay, now what is the probability that the batter hits, you know, at least, you know, somewhere x equals 1 or 2 home runs? Okay, so what you would do is you would take the probability of 1 home run, which is x equals 1, and then you add with the probability of x equals 2, and that would equal about 0.17% of the time. That's still a huge number for this batter. Why is he not in the majors is what I'm saying. Okay, and so this is how you set up everything and just work with it. Just make sure you understand that when you're looking for something, look for the complement. I mean, something like that. So, for example, the probability of, let me see, the batter x not equal to 3 or more is the same as 1 minus the probability of x being equal to 3 or more. Okay, and that in turn actually turns out to be 1 minus 0.03, which is equal to about 97% of the time, so 0.97. Okay, all right, and that's it for discrete random variables. It's pretty easy, pretty straightforward. Just make your table, make sure you have your countables up here and then your percentages down here, and it should be really easy to work with. Okay, all right, you guys have a wonderful day, and I'll talk to you later. Bye.